The title of this panel is Stimulating Innovation, Societal Imperatives and Commercial Opportunities. And we gave it that title, but this panel comes out, this discussion comes out of a discussion that the organizing committee, specifically members Sandy Magnus, our executive director, and Dave King, and myself had about, you know, if it were written, it would almost be called a think piece. What we were looking for was not a detailed technical session on, you know, the latest results for improving the link margin between Earth and Mars with a yet more clever coding scheme. Not that there's anything wrong with that, but something at a higher level. And by that higher level, what we talked about is what are the societal implications of the enterprise in which we are engaged, the human and robotic spaceflight enterprise? What comes out of that enterprise that in the larger scale matters to society? And there are an enormous and maybe not even countable number of dimensions to that question, and we're only going to pick 3 or 4 today. But I think the question is worth asking. It might be worth asking again. So I want to start out by emphasizing I'm not talking about spin-offs. There's a mythology, turns out to be untrue, but a mythology that, you know, the space program is responsible for Teflon. Not the case. But even if it were, that's not what I'm talking about. What I'm talking about and what we're trying to talk about with this panel are the larger issues. We will have Cheryl Nickerson talking to us about biomedical matters, things that we're learning about cell biology and how life functions in the microgravity environment. That will teach us about physiology and biology, things that we have never thought before. That will have other implications, probably across a range of biomedical and physiological subjects that I can't even pronounce the names properly. What will we learn from that? What are the implications of that for the human society of the future? We're embarked on a new frontier. Bill Martell is going to share impressions with us about the implications of exploring, exploiting, expanding, defining, probing that new frontier from a national security perspective. What does that mean to society? Is there a society which has ever survived, which has not been on its frontier or the frontiers of its times? These are the kinds of larger implications that the century-old development of aviation and now aviation and spaceflight, these are the kinds of questions that these developments pose for us, and that all too often as engineers we really don't answer. What we provide as engineers is we provide the how. We don't do a very good job of even addressing what the why is. And all too often, I'll share an opinion, my thought is that the why questions are left to policymakers in Washington who are not as fully informed as they might be about what the why questions are, because they don't know anything about the how. And we need a better marriage between how and why than we have had, and it has been my goal in my term as president of AIAA to re-engage our institute and our society in this discussion, this merger of both how and why. You know, how do we do what we do, and why should we do it at all, and what are the implications of it? When I was a youngster in this business, the AIAA was routinely sought out for its opinions by policymakers, its opinions as an institute on what we should do and why we ought to do that as opposed to some other choice. Policy is about making choices. We, this institute, the largest aerospace professional society in the world, should be engaged in that debate. And Sandy and I are trying to take us there. So this is not the first of those types of sessions, but one of them, and we certainly believe not the last. So with that intro, I will do a brief introduction of today's speakers. Our format will be something like 5 to 10 minutes from each speaker on a topic of their choice in their general area of expertise, and then what I would very much like to do is to throw things open to questions and discussions from the audience. Hopefully we can have discussion both among the panel and with the panel and the audience. All of you know me, and you know that I am a very informal person and like to run things that way. The purpose of this session is intellectual exchange. So with that, our truly excellent AIAA staff provided me with speakers' bios so that I don't forget things. The only real danger was that I would forget my reading glasses, which very nearly happened. Had to run back to my room.
You need mine.
No, I'm good.
Yeah.
No, thanks. Yeah, it'd be a disaster area without them because you can't expand the font on the printed paper, you know, like on the iPad. Our first speaker will be Tim Budzik, who is managing director for the Houston Technology Center JSC campus, and that pretty much tells you what he does. He's responsible for client incubation and acceleration at Houston Technology Center across a range of energy, defense, IT, cyber, aerospace, all that sort of thing. In a prior life, Tim was Director of Business Development for EADS North America, certainly an interesting enterprise, and also was a Senior Business Development Manager at United Space Alliance. So Tim comes to us not only with a background in aerospace, but a background in broader technology, and that's exactly what we're looking for. Bill Martell is a professional and now a personal acquaintance of mine, an associate professor of international security studies. He teaches both at the Naval War College and at Tufts University, and is a thought leader in national security affairs and in particular national security space. I'm thrilled to have him on board. And finally, Cheryl Nickerson is Dr. Nickerson has her PhD in microbiology and biochemistry from Louisiana State University in Baton Rouge, following degrees in a bachelor's and master's degree from Tulane and University of Missouri. She is a life scientist, internationally recognized in her research in utilizing the microgravity environment as a research platform to study how physical forces dictate the outcome of host pathogen interactions that lead to infectious disease. You might remember a few years ago, and I remember because I was still at NASA at the time, and you know, my colleague Bill Gerstenmaier in the back of the room and I faced a situation in which we demonstrated the incredibly augmented virulence of the salmonella virus in zero-G. And we started screening for that, and that was a research result that Cheryl's group produced. A very shocking result. Why is it that a particular pathogen should become ever stronger in zero-G than had ever been the case in a 1G environment? These kinds of questions must have profound implications for the future of human society, and Cheryl will tell us a little bit about them. So with that, Tim, the first 10 minutes are yours.
Thank you, Mike. I really appreciate that. And my other panel members, I really appreciate the opportunity to be here with you. Yeah. Thanks. My focus, in a sense, is what we've been doing in seeing a change in the thought processes around space exploration. Primarily, a lot of the work that we've been doing has been, or all the work that I've been doing with the JSC has been with the Johnson Space Center. It's been a growing evolution that in order for NASA to reach the goals that they want to get to for space exploration, the federal agencies can start and you know that's what's happening with low Earth orbit. You know they're finally transitioning that. You know, that goes all the way back to Christopher Columbus. That was a government-funded voyage that discovered the New World. It wasn't the East India Trading Company. So you have to have the federal government to kind of lead the way. some things that you can say is low Earth orbit now, in that transition to this commercial space, is exactly a transfer of technology from a grander scale than any one individual component. The whole process, that is over the last so many years, we've gotten to the point where we expect it, we know it. Commercial space is not new. We've been flying commercial satellites for a long time. What is new is the emergence of a new kind of approach, a new vision around an industry that is non-military, non-federal, and that is space tourism. Is it enough? I don't know. But right now, what we're seeing is an emergence of that. One of the things, I have a video that I'll show in just a minute that talks about the 4th largest city in the country transitioning and changing its thought process to be a spaceport. That thought process is the same thing that we see on the ground at the leadership with Johnson Space Center, as well as throughout the technology transfer groups, that there's a number of technologies, there's a draw from society that still, they like the meatball idea, association with NASA. They want to be involved with that. Industry still sees that as a value proposition. But in order to meet the goals of the future, we have to have more industry involvement. What we represent at the Houston Technology Center is that industry representation tactically on the ground with Johnson Space Center. It's not that we're evaluating technology. It's not for us or any of us to necessarily pick out which technology it needs to be, but technology alone does not make a business. Our idea is, what is the business around a technology? The technology is only 10%. The other 90% is all about the business. How are you going to take it to market? What problem are you trying to solve? What's your value proposition? What's the management team look like? What's your operational plan? How are you going to support those things? All those things have to be in place. And that's a different methodology than typically that we've seen in a federal program. And that is, that's by design. I mean, the federal programs are large programs. You have program management, you have schedules, you have those things, your resources have to be there, you have technology challenges have to be overcome. Those are all processes to go through. But what's missing in order to change that technology to commercial or to introduce it to industry is we have to see a commercial return on investment. And I kind of what I want to do now is transition over to the video, and that is, you'll see a shift in thinking. And like I said, I'll get back onto it because it's just, to me, it came as a bit of a surprise that they had talked about it, but that it came out just last week in the press that Houston is getting behind this idea, and this is the video on it. See if I can switch over to it.
We believe that the 20th century was about the development and the evolution of aviation, beginning in 1903 with the Wright brothers demonstrating heavier than air flight. The 21st century will be about the evolution and development of aerospace, and the two are converging as we speak.
We've talked about it for many, many years, but we're at that cusp where we might be able to see commercial space become a reality. Houston is a great opportunity and great environment for that to happen. Not only are we located right near the Johnson Space Center, but Ellington Airport, the possibility of Ellington being an Ellington spaceport.
What do you do with an airport like Ellington that has a general aviation military history, for all its years, one of the oldest airports in the United States, but it's basically a general aviation military. Until you look past the boundaries of the airport and you notice that you have agencies like NASA and Johnson Space Center, and you have companies like Boeing and Lockheed Martin, and you have Grumman, and you have a lot of other aviation or aerospace companies, and then you have the universities here. All these universities, each one of which has an aerospace component. And you look at Ellington, and only perhaps less than a third of it is actually occupied by general aviation and military. The rest is sitting there. And then the thought comes of the transition that is taking place in the United States from a federal space program to a commercial space program. We're in the infancy of a new industry. There was a report that valued the aerospace industry worldwide today at about $256 billion in 2010, and it's growing at about 5 to 8% compounded annually.
Texas is open for business. Not only is housing affordable, but industry here is very accommodating to new businesses. Unlike any place else in the country, this environment is gauged around how to make a company successful, whether it be aerospace, energy, IT, or life sciences. It really doesn't matter. All of those come together in Houston.
All of manned flights, every one of them, has been managed, has been controlled, has been guided from Houston. And so Houston is a natural in terms of continued space exploration, space development. Imagine in 1903, the Wright brothers first taking off in this aircraft with a little putt-putt motor in it, and the century ending with an aircraft like the Airbus A380 that can carry over 565 people to just about any point on the world in absolute luxury. Imagine where we will be at the end of this century. Space is the new ocean for the world. And today, what man is doing is dipping its toe into the near space, starting to understand how to live in this new vast ocean. And we are just learning how to do that. And we will see terminals, not like terminals we have today, with decompression chambers and all kinds of centrifuges to train astronauts and train people that will be going into space. And so all of it can take place within the infrastructure, the buildings, whether they're high bay hangars or they're logistics centers or research and development laboratories or centrifuges or just space, education space, office space, all of which can be built in Ellington in a setting, in an environment that is conducive to thinking, so that in the future, just as people today, when they think about computer chips and they think about applications, think about Silicon Valley. In the future, when these people think about space, they'll think about Houston.
I don't know.
Was asking if that turned itself off, and I guess the answer is yes. Thanks, Tim. That was great. If nobody else asks it, I've got a question for you about the return on investment stuff, but we'll hold that a little bit later. So, but we should be a good discussion. Bill Martell, I've already outlined Bill's background in the national security arena. So, Bill, the show is yours.
Mike, thank you very much. Thank you for the very kind introduction. I'm going to talk about something a little somewhat different in many ways. And I want to begin really with a point that I think we lose here in this society, and we have for quite a long time. Unlike most of American history, from the time of the late 40s until the early late 90s, we had an unusually coherent view of that which was required to defend the nation and to promote it both in political, economic, military, and technological terms. And the buzzword of late in the policy scholarly world is that of something called grand strategy. And grand strategy articulates, explicates what it is you believe, what your broad vision for the society is in the conduct of both, and this is important, both domestic and national security affairs. That consensus was formed at the end of the Second World War, really, and in fact, FDR was being warned routinely by Churchill that the next great threat facing the U.S. and the West would be the Soviet Union. Well, the Soviet Union, interestingly, compelled in many ways a very coherent, very focused approach by the country, and many at the time, I think correctly, believed that it was related to protecting and ensuring the survival and prosperity of the country. That was an interesting period. It's unlike really any other periods in American history, and I think we have to think in terms of the implications of that strategy for American national security and for space. Unlike then, now we're really shifting about or in search of a set of concepts to define what it is we care about. Now, if you wonder why that matters, I think it matters because most of what we did in space began in the 1940s and 1950s, largely driven by defense, largely driven by nuclear weapons, largely driven by ballistic missile technology, all of which were designed and organized precisely to protect and promote and defend the country. And most of what we did as a country from the 1940s and 50s on was in the realm of space, was directly a product of a national political consensus that really resonated from the top leadership in the White House down through most of American society as to why we cared about space. And if you think about the resources we applied to space during that time, they were significant, and we didn't really hear, I'm sure, maybe the inner circles we heard, but as a society, the consensus was this is immensely important. It's something on which we need to invest resources, and we really didn't nickel and dime ourselves over the budgets that were being produced. So from a time when we had this very coherent national grand strategy on what it is we're trying to accomplish, how space fits into that, we have the end of the Cold War, and we've really been, and really for longer than the end of the Cold War, we've been struggling as a society on trying to build this consensus on space. Now, a quick but probably wrong conclusion would be that as a society and as a nation, we have disengaged from space. When I was watching Tim's video, I flew into Washington. I think it was in April, and how many fly into Washington on a regular basis? And I landed at National, jump in a cab, and the parkway is really a parking lot, and the traffic is inching along. People are parked on both sides of this, and finally the cab driver says, "Look out the window. You'll see the shuttle flying overhead on a 747." Now, what's interesting about that, of course, you have to stop. You have to look out the window. I took my phone out. I'm taking pictures. But what's most interesting is the reports in Washington is tens and tens and tens of thousands of people left office buildings. Where I went up through Foggy Bottom by State and over to the White House, you could just see the sidewalks were packed with people. My quick conclusion was that there is, in fact, it still resonates with the American people that space is something important that they care about. So the problem that we confront as a society is that what space exemplified for us or typified for us was a way to push two, really maybe three important components. One is to protect the nation and keep it safe in terms of defense and national security. Space programs, satellite programs, all of that were a function of our space program. A second was the commercial side of space. That is, we understood as a country that spending government money will encourage the private sector to invest in, build, and develop lots of, as the social scientist in me, the policy type would say, very cool technologies, and that's pretty very important part of the thinking. And that enhances commercial capabilities on the country. It taps into those and draws from them. The third is it builds what you could call a national ethos on why space is important. Now, the good news is that that's something that all societies ought to have. The bad news is, I think, it's probably hard for this to bubble up from below. This is something that has to be articulated by national leadership. And the national leadership has to be committed to the propositions that A, this is critical for national defense, B, it's critical for commercial purposes, and C, it's critical for maintaining and caring for the nation's sense of enthusiasm, of place in the international system, which I think are so much exemplified by what we do in space. Now, short of having that national leadership on space, our discussions about what American society ought to be doing in space will tend to have I hate to say it, but almost a stillborn kind of quality. It can't manifest itself until we have a commitment on the part of leadership that these are important things that we need to engage in. I think my view now is If I look at budgets and I look at the policy debates going on here in the States, I don't think that space is anywhere near where it ought to be in importance for the society. Moreover and worse, I sense other societies have drawn precisely the opposite conclusion, which is that space is immensely important to all that they need to do to be competitive, both in terms of security, commercial capabilities, technology, and in terms of a national sense of doing something important. And I think what this will pose for American society is a very fundamental choice. Either we will, because of our own internal forces, will be driven toward re-engaging in space. I know all the debates about where do we go and how fast do we get there and when do we go there. My view has always been, for what it's worth, is that it matters. It's important to go places. It's more important to be in the process of going places. And I remember vividly as a kid the sense of enthusiasm as we made remarkable accomplishments in space. And I sense that's something that we can return to. So either this will emerge out of the, if you will, the body politic of the United States, or more worryingly, we will confront again another moment as we confronted in 1957 when the Soviet Union put up Sputnik. I refer to that casually as being kicked in the teeth. And as the English philosopher John Donne once expressed, the prospect of being hanged in a fortnight sharpens the mind wonderfully. And I think there is some component to that in terms of how we organize for space. I can give you a couple of possibilities. Any kind of political confrontation on a global scale could regenerate that. I also suspect that I'm curious as to the reaction of the American people if at some point we watch others plant flags on the moon. And I suspect that may have a bit of a motivating quality to the society. So for me, as I summarize, if we once had a coherent strategy for what we were trying to accomplish, and space was derivative of that. We didn't pursue space simply because space is a cool place to go and it's neat and it has energizing qualities for society. We did so for very coherent national reasons related to security, economics, and to really national ethos and national spirit. That has eroded clearly, and now the question I think for the space community and for the policy community is how either to change this trajectory or how to maintain the building blocks in place so that we can re-engage when the moment occurs. If history has if there's any interesting qualities of history, it is that history is unpredictable. What we think is unlikely now will turn out to be the strategic reality of tomorrow. And so I'm a strong believer that what we ought to be doing is trying to, as a society, prepare ourselves for a moment when we will once again inevitably conclude space is an important part of our national strategy and an important part of what the society is and what it seeks and aspires to be in the future. And I'm sure there will be questions and comments we can deal with later. Thank you so much.
That was good. It seems as if when I hear your remarks, I almost would abstract, not to put words in your mouth, that currently we're in a Billy Mitchell moment in space as an analog to aviation, where despite the early intense interest in aviation very early in the 20th century and the initial growth of air power as an influence in World War I, somehow as we passed out of that immediate conflict,
Yes.
the fact that air power was indeed strategic was lost on policymakers
And the Navy
for a generation.
And the Navy concluded that there's no way that aircraft can bomb ships.
Can bomb
ships.
And we don't have to worry about that.
Yeah, and then, whoops, later a subsequent generation found out that the lack of appreciation for the strategic nature of air power had consequences which then had to be remedied. Yeah, I mean, interesting. I had not actually thought about that previously. Good remarks. Cheryl, if you would, take us in a new direction.
I will be happy to do so while still aligning with the common
Can everyone
direction.
hear?
Can you hear me okay? Am I all right?
I think that
I've got a pretty good
I
set
think
of
a microphone
lungs.
needs to be close to your lips.
So what I'm going to do is take us in a bit of a different direction, but while still staying with a synergistic alignment. And what I'm gathering from my esteemed colleagues is thinking outside the box. The need to think outside of the box applies to all aspects of spaceflight, especially spaceflight research. I come from a biomedical perspective. So I'm going to talk to you a little bit about the tremendous potential, the tremendous untapped potential at this point in time of using the environment, the novel enabling discovery platform of spaceflight, to provide next generation breakthroughs in biomedical and biotechnological advancements that cannot be achieved using conventional methods. So why is that important, you would say? Why is that important? Well, so far, spaceflight and microgravity research done as spaceflight has provided us some of the most intriguing clues. And we're on the precipice of what I believe had the potential to be major discoveries in a wide range of biomedical fields, which are the leading causes of human morbidity and mortality on this earth, and which discoveries cannot be made using conventional experimental conditions on Earth, where the force of gravity can often mask key responses that your cells are making. But if you could unveil these responses, they could tell you, are these cells going to behave normally, or are they going to transition to disease? So I think, moreover, the designation of the International Space Station as a United States national laboratory clearly underscores the significance and the importance that our government, our country places on the ability of this platform to provide novel insight into fundamental biomedical, biological problems that can't be achieved by other means. By way of example, infectious disease, immunology, cancer, bone and muscle wasting loss diseases, and neurological disorders. Oh, and by the way, aging. If those sound like leading causes of problems and health challenges that we have here on this earth, they are. And those are all prime examples of areas in which spaceflight discoveries, the responses of cells and tissues and organisms to culture in this unique environment where you greatly remove the force of gravity, has unveiled novel cellular and molecular response mechanisms that are important for cells to determine whether they're going to behave normally or transition to disease-causing properties that in many instances cannot be determined on Earth. Now you're going to say to me, now wait a minute, we have a plethora, we have decades, centuries of discoveries with biological systems and how they behave normally or not, and you're right. We have made amazing advances in our understanding of disease and disease mechanisms. But we always want to not have to treat disease. It'd be nice to treat health, to maintain health, especially as we're going towards personalized medicine. But we've missed, there's a gap in cellular and biological understanding that we've missed because the force of gravity masks a number of these responses. So let me just give you by way of example. Research in my laboratory is focused on using this innovative discovery platform of microgravity to provide novel insights to advance the fields of infectious disease, vaccine development, and tissue engineering. Okay? And again, remembering each time we're using the microgravity platform for each one of those fields, we've been able to find that cells are behaving in biomedically relevant ways that they don't when we culture them here on the ground. And so we're taking these novel cellular responses from both microbial pathogen cells and human cells in my lab that we work with, and we're working to translate them towards novel strategies to treat, prevent, and combat diseases. So let me give you an example about how we're doing this. And Mike mentioned that previously my laboratory had discovered that the major foodborne bacterial pathogen Salmonella, which causes 2 to 4 million cases of foodborne illness in this country alone and costs the U.S. economy between $2 to $4 billion in lost economic income, because if you can't work, you know, it may not kill you in the U.S., but if you can't work, you can't go to work. Let me just back up just a minute and tell you why infectious disease is important to look at to find novel discoveries. Infectious diseases causes over 1/3 of all the deaths globally. In the U.S. alone, it costs $120 billion in the U.S. alone. It's the leading killer of children and young adults globally. For many causes of infectious disease, we don't have efficacious treatments or vaccines. And we continually have to be worried about infectious diseases as a problem because we are continually seeing new and reemerging more potent infectious diseases. Antibiotic and antimicrobial resistance is on the rise. And unfortunately, in the current paradigm of our world in which we find ourselves living globally, we have to be worried about biosecurity threats of inappropriate use of biological agents as weapons of terrorism. It also takes, on average, 10 years and $1 billion for any drug to be brought to market. So we have to be able to outpace infectious diseases, and that's a very difficult challenge. We need new ways, new platforms to use to uncover and unveil ways that pathogens are changing, about how pathogens actually cause disease in the body. And any platform that can give you this kind of novel insight, which can reduce the amount of cost it takes to get a drug to market, which can reduce the time it takes for patients to have to wait for that drug, must be explored. And extreme environments, spaceflight's it's an extreme environment. And any biological scientist will tell you some of the biggest paradigm changes we have made in our history have been studying the response of cells and biological systems to extreme environments, whether it's pH, whether it's temperature. We have been able to take those novel responses and make translational advances to prove human health and quality of life. So when my colleagues say to me, why would you think to marry spaceflight for infectious disease insights? Why would you think to marry spaceflight for tissue engineering improvements, which we're also doing? We're working to engineer tissues outside the body using this technology and this platform that can be used for us as human surrogate models for us to understand how your tissues respond to that infection. We're screening antimicrobial drugs with them now to find out how those tissues respond to those drugs. We're screening them with toxins, and we're finding out those cell-based tissue models that we've constructed with this technology outside of the body respond in key ways that your tissues do to infection. We are now working closely with transplant surgeons to take these tissue models and seed them with stem cells, or we're using decellularized organs. And then we're reseeding them with patient stem cells using these technologies and microgravity analog technologies for regenerative medicine and transplant, potentially, in the future, for transplant of organs. So I just want to take a step back and say, yes, Michael mentioned that, my laboratory had discovered new ways that salmonella causes diseases by flying it in microgravity and culturing it under those conditions. And there currently is no vaccine against foodborne infectious salmonellosis and against a lot of other pathogens. So we found that spaceflight uniquely increased the virulence of salmonella. And then we looked at all the genes whose expression changed in response to that spaceflight culture. And what was amazing to us is that the genes which are conventionally known to be responsible for causing salmonella's a disease-causing potential or virulence weren't switched on and off in the same way up there as they are down here. And we identified new targets, and having a better understanding of how salmonella is causing disease, we flew a translational experiment to see if we could develop better vaccines against a variety of infectious diseases using the microgravity environment. So vaccines, infectious diseases, engineering functional tissues outside of the body which are better able to mimic some of the key responses and functions that your tissues have, to apply them to a variety of important topics, to understand how pathogens cause disease in your body, to hopefully in the future be able to do tissue regeneration and autologous organ transplant. These are just some examples of the power, of the value, of the incredible importance of utilizing this platform, and if you would so allow me one extra minute here, utilizing this platform now. I'm saying now because we are on the precipice of losing, and I mean the very precipice of losing the value and the ability to use the microgravity platform of the International Space Station for this type of next generation breakthrough biomedical research because of a lack of consistent funding and access to the platform. We need government, academia, and industry to work together. We need consistent funding streams. We need to make this happen now, because this is not the time for the U.S. to punch our ticket, to get out of the game and take a grandstand seat and watch our international colleagues, because they are investing the time and they are investing the money because they get it. And they're going to use it. And now is the time for this country to make a decided, a committed, and an immediate investment for the global advancement of human health and quality of life in the biomedical fields. Because if we don't, we're not going to know the world that's handed to us in these fields in the next decade by other countries that will do it, because they do get it. We have one chance to use this ISS National Lab, the most amazing, permanent, semi-permanent, I wish it was permanent. Michael, can you make it permanent? Semi-permanent laboratory for
I got fired,
biomedical-
Cheryl.
for biomedical discoveries that has ever existed in our lifetime and which we will not have in our lifetime again. We cannot not afford to invest in it.
I think we should send you over to the commercial crew panel.
Yeah, exactly.
Just kidding. You know, it's interesting. I hear the last two speakers speak, and the question that immediately pops into my mind or a question that pops in, I always have lots of questions, wonder what the national security implications are of the U.S., of U.S. scientific researchers figuring out the mechanism for infectious disease and then going from there to being able to deal with it. Wonder what that does for national security. That's an interesting thought. But others have interesting thoughts. So thanks to each of you. Those were disparate, but all good. So from our audience, I'm the moderator. That's what I'm doing. So I'll fill in with some questions if you guys wimp out on me. But I'd like to get some questions and discussion going here. So, sir?
I have a comment and then I have a question.
Comment, short comment, question, please.
You see the roadmaps of Russia, China,
Yes.
Japan, India. They claim that Moon is on the way to Mars. It is a step to go to Mars. And their roadmaps say we're going to explore the Moon. I'm wondering how we're going to take that in the next couple of days.
Well, I think Bill commented on that a little bit, but and I certainly have my own thoughts, but I don't want to interject those yet. But panelists, Bill, why don't you start? We've all seen, I think most of us here have seen those briefings that have come from. I've seen them from China, India, Russia. We've all seen them. What do you think about all that?
Several thoughts. One, on my more waggish side, I want to observe it's going to take us longer to get to the moon the second time than the first time, and that's a scary thought. It's interesting that we have concluded space just isn't that important, and I don't think I'm being unfair, but attack if you think I am. I don't sense at all that the national leadership, and I'm being as bipartisan as humanly possible, cares very much about space. I think it's so low on the rungs of priority that I think it's a rounding error kind of issue. For a second, I'm not clear why it is others find it so crystal clear that they think it's important, when the Russians, the Chinese, and so many other countries think it important to be in space, and we haven't drawn that conclusion. I might observe that one explanation for this is two-part. First, we've been in an economic downturn now since 2007, 2008, so we're running a 5-6 year kind of economic stasis. And second, as we probably saw in the debate here in the States in the last 2 weeks over Syria, there's probably a bit of a war weariness. So I think from a number of points of view, there's a sense, I have a sense, and I think Americans have a sense, that the country is somewhat tired. I might add a final point to that. A lot of the thinking classically about what I called earlier grand strategy, when people say grand strategy, they mostly think national security, foreign policy stuff. And that's fair. The second component is as important, and it's the domestic foundations of power. And I think I would submit to you, that we have spent, other than the 30s and 40s and sort of and running along through 50s and 60s and the 70s, we were pretty good at building national infrastructure, emphasizing education. Think about the burst of interest in engineering, science, technology, mathematics after Sputnik. We haven't been having that degree of emphasis lately. And I sense that there's a shift that's occurring in American society where we're focusing a little bit less on national security issues, we're focusing more on domestic foundations of power. Now, the weird part is, if that's all true, and I think it is, then there ought to be an emphasis on the technology foundations of American power, of which space remains a very good investment, albeit at relatively low budget levels. We were talking prior to this panel, our economy is running, what, $15 trillion a year in GDP. We're spending, what, I don't know, maybe $20 billion a year. Is that, are my numbers correct on NASA? My way, 17, okay.
17, yeah.
Close number.
I wish it were 20.
17, okay, so close number government work, $17 billion. A $15 or $16 trillion a year economy is debating spending that kind of money when the Federal Reserve buys $85 billion worth of bonds every month. We have priorities that are so completely out of balance, and I think the moon is a function of that confusion and paralysis.
I'll give you a statistic, not mine, but I love it, from our colleague Scott Pace, who runs the Space Policy Institute at George Washington, that all of the money ever spent on NASA is less than the amount that was voted for the fiscal bailout in the winter of 08-09.
Yes, yes.
All of the money ever spent, for which you got Apollo, shuttles, space station, all of that was less than the fiscal bailout voted in 1 year. So clearly it is not a means issue, it is a priority issue, which is the point you're making.
I'd make one just other brief comment. It is a true but unfortunate quality of democracies. We love democracies. Everybody knows Churchill's quote, democracy is the worst form of government except for all the rest. Mm-hmm. The reality is democracies by and large need external forces to make them coherent and to drive them in critical directions. And if you look back in American history, when we have really become energized, it's because somebody kicked us in the teeth, either imminently or directly.
Yep.
You know, we talked about, I have a question for you, if you don't mind.
Oh, I'm good.
And the moderator.
He doesn't care where the questions come from.
But you know, we've grown up in an era when we were following the Apollo program, the Gemini program, those sort of things. It was a sense of threat, that there was an evil enemy, the evil empire, the Iron Curtain. That was what we all believed. Do you think that's what's missing to motivate us to move into space?
Absolutely, Tim. I think unlike the Second World War, where we really considered the possibility that Germany and Japan could win, unlike the Cold War, when the rhetoric was pretty heated, when you think back to the language that was used by both sides to describe what we would do unflinchingly to the other, I think what's missing entirely, and this is probably a good thing, I think it's missing entirely from American consciousness the possibility of being defeated or seriously disrupted in any significant way. I say that on 9/11, on the 12th anniversary of 9/11. Yeah. It is not a part of American society. And if you recall from 9/11, we were instantly moving in a public opinion block of somewhere between 80 and 90% within about 10 minutes of the second tower falling down. We don't have that now. And I think we just don't conceptualize any set of events, actors, players that can do any serious damage to us. And I don't mean that in a war sense. I mean that in any serious political, economic, technological, military sense imaginable.
We do not feel threatened.
No.
When you talk about domestic sources of power, I'm reminded that I love numbers, as you well know. The world lost 55 million people in World War II, of which 500,000 in close round numbers were Americans. The rest of the world lost 100 times the people we lost, and yet if there was a single nation that could have been said to have been determinative in the outcome of that world war, it was the United States. We engineered and built our way to victory. We did not accomplish victory by sacrificing people. At a ratio of 100 to 1. We engineered and built our way out of that. That is that is the domestic source of our power, was our economy and our technology, and we've forgotten it.
And just one other point, we produced, in 1945, the United States produced 50% of total global goods and services. 50%. What are we now? 10% maybe? That's a tremendous concentration of power.
Another
and
question.
I also note, we forget about this as a
Well,
society.
I was going to make a comment. We've talked about the security threat, and we've talked about some other things. One of the things and as far as threats, the cyber threat is a more monumental threat to our way of life, our fundamental way of life, that is a behind-the-curtain threat. My time at EADS, one of the things we were working with in defense security was training security folks that work in DoD. The amount of attacks that we are dealing with on a national basis, President Obama has made up several comments about, it's a worse threat, but is it not that the press has not picked up on it? I mean, from an industry standpoint, could I not influence people by a marketing campaign in some way? That's kind of we need it from a public speak standpoint, but at the same time, it seems as though there's not a cause going out there, or if there is a cause, it's bipolar. It's either one side or the other side, unfortunately. But, unfortunately, we don't have a lot of cyber experts here to talk about it, but the
Well,
cyber
next time.
threat is more. Yeah.
Next time. Some comments, another comment from the audience. Jim, behind you, then you.
Also reminded about this threat. I mean, I asked you to look at a situation where we allow the Chinese to land a man on Mars first, and would that not make them, they would assume the leadership of space and technology, and would that not result in the nations would then tend to see their form of government as preferential to democracy, and that kind of shift globally would be very hard and expensive to recover from, because how do you top man on Mars?
Well, I personally find that before you get to the man on Mars, you will be first topped by the woman returning to the moon in an era when almost no one left alive remembers that it was Americans who did it first. We speak English in this country not because British citizens arrived first, but because British citizens were the most persistent. So I will take your argument and square it. I think it's a critical argument, but I think it's a lot sooner than worrying than Mars. Just throwing in my opinion. Others?
I agree with that. I think that not to specifically identify but if the Chinese, for example, as we indicated, were to go back, their philosophy is so different from ours, a Western style philosophy, that they're not going to go back to visit. They're
No.
going to go back to dominate or to own.
Of course.
Yeah. So would we not then become intruders on the moon when we return?
The failure to occupy a frontier may mean that later on you can't when you want to. Quite well. I want to, Jim, you had a question, and then I have one for Cheryl. But
I've been excited by a lot of stuff at the conference, but this is the first one that's got my emotions going.
I think that was Mike's intention, definitely.
Is that the good news or the bad news?
emotions and engineers. I mean, who would have thought?
The scenario in my head is not that the Chinese land on the moon first, but it's that the Chinese premier in a nice ceremony hands the American flag to President Clinton when they return it from the moon.
Right.
And at that point, I would hope Americans would react at least by saying, "Oh my God, my job is going away," because we're losing sort of the economic as well as the S&P domain. So the question I sort of wanted to get at was, think you're right, we're in a sort of a stasis where national decision-making and leadership is gone. I think that maybe it's time for us to focus on industrial policy, looking and taking care of business at home, making sure we got S&T, tech transfer from what we are doing into industry, and this is an industrial policy issue. It's boring, but it's time for us to dig back in and roll up our sleeves and do that. That sort of goes to what you were talking about
Right.
earlier about AIAA, not getting traction in Congress.
Well, we've done a lot of that to ourselves by, if you're not present at the debate, no one cares what you think. The decisions are made by those who show up, and my comment was that our institute needs to show up. But you're right, industrial policy is not on the nation's table today the way it was when I was a young man. It's just not.
If you don't mind, with industrial policy, that kind of falls into part of our sweet spot. One of the areas that we've been really struggling with is we're sponsored by industry. The Houston Technology Center is actually sponsored by industry. We have input from the Texas Emerging Technology Fund as well as other funds. But when we look at industry, the attraction that we had when we first started working down at JSC was, let me buy a position so that I can get a better position for the federal dollar. But what we're having to have to shift, and industry in the same case, is a lot of the interest when they start trying to first come to NASA. They think about the traditional style of NASA writes a set of requirements, they do it, or they have a problem they need to be solving, they go to industry, they pay industry to solve the problem. What we're trying to do, a lot of the stuff that we're doing with the help of the Texas Emerging Technology Fund, what we're doing at the Houston Technology Center, is really trying to change that paradigm to where if we have complementary challenges, that working together we can synergize for a solution. Or we could look for other forms of money. There's some specific examples that we can talk about, but those are cases where industry has come in, and once they found out, oh, you can't pay us to do something, and they turn away. And what we really need to do is we do need to change the industrial mindset, in a sense, to be part of the solution.
Well,
and definitely.
Right. The evolution of the aviation and space industry, I think it's worth noting, and I do want to transition to some of the medical issues,
Yeah.
but I think it's worth noting that much of our aerospace industrial base arising out of the national security establishment to which Bill referred earlier has now gone for 3 generations accepting as a normal business relationship, one which was technically illegal before 1949. Mm-hmm. And that is what we commonly refer to as the prime contract in industry, what a lawyer would call a negotiated contract, was a wartime exception in World War II. Prior to that, it was understood that that the government would buy its things through what would be a conventional arm's length commercial contract. The government publishes a notice of what it wants and bidders provide that. That doesn't work, or make offers, tender offers. That doesn't work well in a wartime economy, and it doesn't work well for things as large as, say, a B-29. When you don't have a B-29 and you want one, it's a little bit difficult to get industry to build one on spec. So we evolved a contracting system whereby, I won't describe it, we all know what we have, and it has now in our industry almost uniquely become accepted as the way to do business. Yeah. But as Tim is pointing out, it utterly removes any sense of entrepreneurship, competition, all that. It's not been healthy.
I would add, if I might, I just add a comment. I am not into doom and gloom, and I think one of the most, if not the most important component of American society is we're innovative when we're on vacation. We are much more innovative than the rest of the planet, in my humble opinion. For a second, In the 1980s, that whole debate about the decline of the U.S., remember the book that came out? Remember Rise and Fall of Great Powers, Paul Kennedy? Whole debate, late 80s, actually 89, 87, 88, 89, this broke out. And the argument was, we're going to collapse in the face of the economic power of Japan. They're just so much better than we are. Well, Japan's been in a 20-year economic downturn. Thank you very much. And we did not. And we picked up and actually implemented in industry a lot of things that made the Japanese, quote, very good. In the last 6 months or a year, I've seen a number of reports, Wall Street Journal, others, which are suggesting we, in fact, are beginning to become so much more competitive in engineering and manufacturing than, say, the Chinese, among others, that work that should be shifting there is coming back to the States. Mm-hmm. And so I think mostly what we're describing here is a combination of bad leadership, and I'm doing that in a nonpartisan, bipartisan sense. We can spread the blame all over the place. And second, an economy that's been in recession for 5 or 6 years. I had a food fight with somebody after a debate, after a discussion on public radio. He said, we're not really in a recession. I said 71% of the American people believe in polling data the economy is in a recession and think it will get worse later. And 2/3 of our economy is domestic spending, is consumer spending. So I think partly what we're seeing is just the residue of this economic downturn. And if I were the Chinese, the Russians, the Japanese, the Indians, or others, I'd be really nervous when whatever event occurs launches this country off into another period of great economic prosperity. It's going to happen. Yeah. When, I don't quite know. Something it'll pop. You all know it'll pop out of the blue, and we'll know it after it actually began to occur. And I think so. Part of what we're seeing here, and I think that plus external competition on space issues will drive us back in that direction.
I've got to get to a question which is on
Cheryl
my
feels
mind
left
with
out.
regard to the whole infectious disease thing because of the way it couples into other stuff. So I'm not sure that I remember my numbers as well as I would like, but I believe that I recall that something over 20 million people died in the influenza pandemic of 1918-ish. Is that about right?
More people died in that than all of our wars combined and in the current HIV pandemic. Yes.
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 Okay. So it seems that these kinds of things come along, if you look at history, not every year or every decade, but every some number of decades we encounter something like this, which is quite harmful. I wonder what the societal implications would be of learning enough about how infectious disease takes root and propagates, that learning the mechanism, we could then deal with it better. And if there's a link there to the research that you're able to do in space, I wonder if we've never looked at it from that perspective.
Well, it's absolutely a link. It's a key link. If you want to understand how a microbial pathogen causes infection and disease in your body, you have to understand two basic things. Number one, what the pathogen is doing when it enters your body at a molecular level, a cellular level, and then you have an immune system. So likewise, it's this dynamic battle between the pathogen and the host, and it is very complicated. We don't understand the whole thing here. Okay, in part, because we have areas of gaps that we can't fill in with conventional experimental approaches, but it's very complicated. So you need to understand what the pathogen is doing, and you need to understand what your body is doing. Because I kind of view it as a very amazing game of poker, where one is continually raising the stakes over the other one. And usually, your immune system wins usually, but we have to remember in the United States alone, you still have a tremendous amount of lost economic impact and also suffering from individuals who get sick from infectious diseases. Due to our infrastructure, infectious disease isn't usually a big cause of mortality in this country, but it surely is globally. And we need to do much better and be much better about being good global stewards for those countries, those developing countries, who the leading cause of death in their countries is because of infectious diseases. So if we can understand at a molecular, at a cellular level, We can unveil new insight into how pathogens are doing what they're doing in our body, into how our bodies are responding to those pathogens. Any platform that you can use to open up that unique kind of understanding absolutely is driven towards novel strategies, whether it's therapeutics or vaccines or drugs, to help us outpace infectious disease. Because as I mentioned, we are not outpacing it now. They can evolve, the microbes can evolve much more quickly than we can. And this also gets into a question of evolution. We now have a platform that instead of having short shuttle missions to learn the information out, we can look at long-term evolution of organisms. And by the way, the most contaminated thing you send up in space is a human. Because 10 times more of the cells in your body are microbial than they are your own, and you wouldn't even exist if you didn't have those microbial cells. I mean, they control your immune system development, they control your cell differentiation and function, they control how you metabolize and break down food. They control whether or not you can develop certain forms of cancer. They control so much about you that we really, not just in understanding how pathogens evolve, because, you know, the crews, we have, for the crew that's flying, you have literally hundreds of thousands of people that do everything they can, screen their health, make sure things going up are as clean as possible. It's not sterile. But but even then they can and have gotten sick up there from infection. So part of our research is we want to do everything we can to mitigate the risk of infectious disease for the crew, especially when they're going to travel further out and can't get back down quickly, you know, for help. But taking that novel understanding and translating it here so we can fundamentally understand this is the type of approach we need, this is the strategy, this is the drug. Only when you dissect and are able to unveil this new insight can you really fundamentally come up with better treatments and better strategies. And these kinds of extreme environments can do that. And if you would, I wanted to add to one thing that my esteemed colleagues have been mentioning about, you know, funding, and they are esteemed, very esteemed. We suffer in the microgravity research field, especially in the life sciences field, from a lack of funding, not because NASA doesn't want to give funding, they do, and they've been very generous at it. But as we just mentioned, NASA is an agency that probably more than any other one is asked to do more with less. And I can't envision many more agencies that are more fundamentally important to our nation's economy, security, education, you name it, right?
Well,
R&D.
any agency carries out policy direction. They might get asked what the policy ought to be, but they don't. In the end, they carry out policy. They don't generate it.
But NASA has done a phenomenal job of funding research. In the beginning, there was no connection. There was no known connection between infectious disease and spaceflight when NASA took a chance on us and funded our work. Now there is, and we have since shown that other microbial pathogens behave in some conserved, evolutionarily similar manners to what Salmonella does on orbit. And that's not just important for the crew, it's important for here. But I think one thing I wanted to mention in terms of funding, when the International Space Station was built, there was, I think, this amazing, spectacular engineering feat was kind of put up there and said, build it and they will come. The scientists, they will come. You put it up there, they'll come. Unfortunately, that's not the way science works, okay? So that was a bit of a fundamental flaw in thinking, well, how are most scientists funded? Most scientists are funded by government, okay? True, there's some corporate and commercial spaces, but most life scientists are funded by the government. Well, at the time, you didn't have any commercial infusion, and you still don't have much of that at all in funding microgravity-based research. In terms of the life sciences, you have almost none, okay? So in thinking about, we're trying to build these consortia, these alignments, multidisciplinary partnerships between academia, between commerce, and between government. That's every bit as essential for all three of the disciplines that we're talking about up here to making this work. It's equally true for life sciences. And honestly, unless you get an immediate infusion of funding from someone besides NASA, because NASA can't stretch their pocketbooks anymore. NIH signed a memorandum of understanding to fly microgravity research and fund it. They did, I helped them write that. They did fund it for 3 years, and then they had to step down. Okay, USDA signed a memorandum of understanding to fund this. They've not put out a research announcement. NSF isn't funding it. Okay? It's not that scientists don't get the incredible potential of it, but I think it seems too difficult, or it's just too challenging, and you have to take a step back and go that it's not the easiest thing to do, but can we really afford to turn our back on an environmental platform like this that has already shown us the kind of breakthrough potential that it could have in a wide variety of fields? And I think the answer is we cannot afford to do this because China has invested $5 billion, with a B, ladies and gentlemen, B as in boy, dollars in 1 year in life sciences microgravity research. In 1 year.
That's kind of incredible. We need to transition to a new topic, but
Sorry.
there's no lack of commitment on that end of the table. There were a couple of questions. I think the lady had a question. So.
Yeah, and that's an excellent question, and one we've, many of us in the field have given great thought to. I will tell you, I talk with commercial spaceflight industries all the time, and there is indeed, the question is there an interest? Oh, there's a big interest. And I would say there's a huge latent pent-up demand, okay? But what they have to see is they have to see that home run hit. They need to see more research done that tells them that they need a competitive edge. What platform that I can use will give me my competitive R&D that will let me get ahead and let me translationally advance these findings? They are waiting for it. They are waiting to see an infusion from government because you can't ask them to pay for the home run. They're not going to pay for the home run. I could have a vaccine right now in my laboratory that's ready to go, and unless everything is right about that, it's not going to get funded, all right? But they're listening and they're watching.
Well,
and if we get an infusion, I think you have to work government first to bring an infusion, NIH, NSF. I think NIH will come back on board. They were there for 3 years. They stood down. But I think if we get that, just show them even more, tempt them, and show them the tremendous potential that's come out of this. Because we've had less than 1 year's worth of research in life sciences, cumulative, since the entire time of microgravity research has been ongoing. How fast do you think you can advance a field also when you can do an experiment one time? Okay, so we need the routine funding. There can be ways to speed up government grants as well. And if I could, let me just tell you why I said we're close to the precipice of not being able to use the microgravity research platform. It goes away in 2020, so we've heard, okay? Hopefully it could be extended a little longer. Let's say there was a research announcement out there right now from the government to write a grant for flight, which there is not. You write it, you wait a year. You bust your behind, you write the grant, you wait a year to hear back. You're funded, you're not. If you're funded, 3 to 6 more years to get the funding in, okay? Now we're at 1.5 years. 2 years average ground-based research, because you get 1 shot to do this right in flight. You need an average of 2 years to validate all your ground-based studies and make sure everything is right. Now we're at what, 3.5 years? You're gonna wait 6, at today's rate, you'll wait 6 months to a year to get at a flight. So now you're at about 2018.5. And the microgravity National Laboratory goes away in 2020. You get to fly once. You don't get to independently validate anything. That's not going to work. If that's the way that the plan is going to go, it's too late. But we can do expedited reviews, peer reviews of directed funding. It doesn't have to take a year. I've sat on panels that have done this. It does not require a year. The government can do expedited, directed research funding. You can get it peer-reviewed, and you can get the fusion of funding into that cadres of investigators' hands in a matter of a very few months and let them get started.
Well, let me break in here because you're touching on issues which I think relate to what Tim was talking about, which is which I'll just summarize as saying business case. Whether you're a scientist or a business person or any other kind of thing, Other than government, most entities cannot afford to put resources into something which will not pay back inside, say, 6 or 7 years. A business case analysis that returns money to an investor past 7 years, well, the value of that dollar today is a dime out then. Yeah, I'll go put my money somewhere else. When we have the kinds of timescales you're talking about, it just becomes impractical as an investor concern. And then when you combine that with a politically established end date for the utility of a laboratory, you lose people. John Glenn has a speech that he gives from time to time, which I remember because I agree so strongly that the United States owes its position in the world to decisions made a century and a half ago that the government would fund and require basic education and would do basic research. And John feels that the accumulation of this intellectual capital over decades is what made us where we are. But it doesn't pay off on a 6 or 7 year time scale that business has to see. It just
So
doesn't.
Mike, could I ask, can we continue to ask?
One more
can I
short
ask-
thing,
okay.
and then I want to transition to some of the other folks who have
So that becomes,
questions.
what you just said is critical, because we now have a nonprofit group in place to manage the ISS National Lab, and their whole goal that they were tasked with was to pair commercial funding and commercial investors with the scientists to fund that research. And so with the comment you just, with your
But see, I
comment you just
can't
made,
put
mean-
my company's money in something which isn't going to pay off for more than 7 years and which isn't even going to be there.
So is the whole premise of this not-for-profit group, do we have?
Well,
what's their
I'm
goal?
discussing, I'm talking too much, but I will
No,
say.
you're not. You're
this-
doing great. I mean, because that's critical to using that platform.
This gets
and
back
how
to
they do it.
the comments that I used to make when I was at NASA this last time, which is simply that, space is strategic for us. This is Bill's thrust and Tim's thrust. Space is strategic. If you believe that an enterprise is strategic, it doesn't have a sunset date. And if you believe that an enterprise is strategic, you don't leave access to it, our space facility, you don't leave access and utilization of it to the vagaries of chance. You don't buy your access to space solely from another country or indeed even any one domestic provider. If something is strategically important to you, you make damn sure you have it covered. And the point that Bill has been making, and you've been making, and Tim and I have been making, is we're not treating space as if it's strategic. No. Hence my comment about we're in a Billy Mitchell era. But let's give some other folks a chance. You've had a question, sir. Let me get to this gentleman here, and then you. So yes, sir.
I live mostly in the ground test world, and so you mentioned strategic and new capabilities to support new technologies, ground test type things or labs that have a fairly long lead time.
Yes.
Now, or strategic now seems to be 2 or 4 year political cycles, or maybe even 1 year with CRs.
See, that's tactics.
Yeah.
Exactly.
Yeah.
And but it takes a long time. Same kind of thing you're talking about for in your world. Same thing on ground test. I mean, it can be 10 years before you can feel the capability. Can AIAA be? You mentioned Billy Mitchell. I worked at AEDC for a long time, and now finally, could AIAA maybe be the next F. Arnold, who with a unitary plan and looking forward and say this is a strategic need for our country to have certain capabilities, and whether it's ground test or flight test or in the labs, I just wonder who can be that. How can we get that? Maybe go around our government. You got me stimulated here.
Well, the goal isn't to go around government, it's to utilize it in a way that we, as people who fundamentally believe in democracy, a way of which we approve.
I don't mean anarchy, but I mean, you have the government, but how can we stimulate what we're doing, our industry, before we get kicked in the teeth?
How can we get our government to make better choices?
But also do more. And I wonder, I don't know, if AIAA could be that, or at least a significant stimulant there, a catalyst.
Well, I do believe that this institute once had a stronger voice in policy making and can again. And I see other professional societies having in the past had such roles, or even now. Another of my organizations, the IEEE, is fundamentally involved in setting things that are crucially important, like wireless standards, you know, coding standards, to name a couple. So I think that is a part of our future, and I and others are working to make it so. But let me transition. This gentleman had another question.
You all have provocative, really wonderful discussion. I have a question on understanding the evolution of life in space. So we have this 1G, we have macro G, we are understanding how life evolved. If you had 8.818 G, 18% gravity, or 38% gravity, I'm talking about medium long.
Now you're on a page that I've been on for some years, which is we need more than just 2 points, because I can draw any curve I want through 2 points.
That's right, that's right.
Wondering your reaction.
I couldn't agree more. I could not agree more. Right now, we have done 99.99% of our life sciences research under unit gravity. And then we've got a fair amount, a small amount of research, focus research that's been done under microgravity. So, you know, we've got between here and Houston. Okay, but life doesn't evolve in a black or white kind of aspect, and even the smallest fundamental changes, especially in physical forces or other things, cells are hardwired to respond to environmental changes. And what may seem too tiny to you doesn't mean that it's not biologically significant to a cell. So I completely agree with you, with Mike. We need to look at partial gravity in different areas of of space that we might find ourselves, whether it's on Mars or the moon or wherever we might find ourselves, because that will, I will guarantee you will see different cellular responses and whether cells are going to behave normally or transition to disease under those conditions. So I could not agree with you more.
Well, I find the shape of I'm sure you're right that there will be differences. I intuit that. I could be wrong, but I intuit that there will be differences. I'm intrigued by a question on what is the shape of the curve. I would be very surprised. It could be this way, but I would be surprised to find that cellular organisms respond linearly to the range between 0 and 1G. Whether the marker is salmonella virulence or calcium shedding by bone cells or whatever, how much gravity is enough to make a difference? How much can you remove and not see hardly any changes? I would be shocked to find it linear, and I'm intrigued by the question of what shapes do the curves have?
Yeah.
And as I say, if you give me only 2 points, I can draw any curve you want between them.
Absolutely. No, you're spot on. You're spot on.
So anyway, so those are interesting topics. And again, what are in writ large, what are the national security implications of being the nation to acquire that knowledge and promulgate it? Sir, you had another question? Loudly so she can hear you. Oh, sorry. I can't hear you.
Spaceports in Houston Spaceport, and it's like, well, there's other spaceports in Russia, KSC, principally NASA. There's another license that you draw some lessons from. What are some of the good things you're bringing in for those, and maybe some improvements and some things you're avoiding?
Why a spaceport in Houston, in other words?
No, what's some of the good things you're bringing into the spaceport? You learn some things you're avoiding, some lessons that other spaceports have taught us that are going to get into.
Well, the one area that what does the spaceport bring, in a sense, is Houston is a very, very fertile ground for new businesses, from an entrepreneurial standpoint. And I'm not saying any other country or any other place in the country is not, but we have sectors in the city, to Texas Medical Center, one of the biggest in the United States, or and I was going to ask Cheryl about stem cell specifically because there's some things happening there, and I wanted to get her opinion on space station work or microgravity on stem cell research.
It's been done. Yeah, people have flown stem cells in microgravity, and with a focus on understanding, what happens to those stem cells? Do they just, are they able to just divide more and be undifferentiated? So you have a big pot of undifferentiated stem cells, or are they driven towards certain lineages and down towards differentiated phenotypes? But some of that work has been flown, and more is being flown. Yeah.
But that kind of thing is local in Houston. The energy sector is local in Houston. The aerospace sector is local in Houston. If you look at those, you look at transportation, we have a spaceport, we have a seaport, we have a lot of things. I think what a spaceport, because they have wonderful spaceports out in the middle of no place in New Mexico. And it's, Spaceport America is a super building. The unfortunate part is there's no infrastructure around it whatsoever. I think the benefit of having a spaceport in a major metropolitan arena, and geographically it's essential that's what drove Houston. New York may have a challenge with it because of population, other places will, but Houston has a unique position, meaning that it has this unique area that's underdeveloped, Ellington Field, that could be expanded, so it has space, so you don't have to overcome that. The kind of profile, obviously, is not vertical launch and vertical, reentry. What we're talking about is horizontal both. And in that case, it's the Virgin Galactic model. If you take the Virgin Galactic model, that is sending a paying customer of $240,000 a space ride for about 6 of them. If that can economically work, then you've got an up and down transport. Now it's suborbital right now, but you cannot imagine that Branson is not already thinking beyond that. He's already made comments that, King of the Moon. Now, whether he can fund it or not, well, that's a different story. But Houston does bring kind of an opportunity. There's other things that'll happen. Now, in the video, he talks about the spaceport being a research park as well as just a spaceport, an innovation park. That's something that we're talking about on a regular basis at Houston. We're talking about working with Johnson Space Center. We're working within an area that's called the JSC Acceleration Center. And that is, they have built places, and this is throughout all of NASA, they have built innovation centers. Now, innovation alone is not technology. Innovation could be, a better way of another process, a better way of handling things. It has a whole myriad of areas that it can touch. But if that innovation touches on technology, and there's a market there from a standpoint of solving a problem for industry, then we say if it sprouts legs, bring it upstairs. We're located in the very same building where the biggest innovation center is. And we have classes in there talking to these astronauts, not astronauts, but the civil servants. And it's two-way. And one is to help them understand what drives and motivates industry. And it's different than what motivates them in what they're trying to do.
Well, industry is about margins, and government is about missions.
Exactly.
I need to.
Please.
I need to. I've been successful in getting questioners to ask short questions, but I'm failing on getting panelists to answer short answers. So,
understand.
Because I want to get more questioners. Yes, sir.
I just wanted to echo what you said. You're absolutely right. I just finished helping with the military.
Louder.
I just helped finish building Antares launch site.
Yes.
The biggest problem they have up there is the lack of infrastructure. It was hard to build out there because we didn't have infrastructure, and it would be hard to launch out there forever until the infrastructure builds up.
Yeah.
And again, Alaska's the same way, so you're hitting the nail on the head. Somebody's been there and done that. Without infrastructure,
Right, and of course, it is, I totally get your point, having lived some of those kinds of campaigns, that without infrastructure around a launch site, life gets very difficult. It's intriguing to remember that the now heavily built up Cape Canaveral area was selected in 1949 as the place that we were going to test what we would today call cruise missiles and things from. We were going to test rockets and experimental vehicles from there precisely because there was nothing around it that could get hurt if things went wrong, right? And so what was then at the dawn of rocketry, what was an attractive feature is now a problem. You know, we need industrial infrastructure, economic infrastructure around our spaceports. So another anything from anyone? Jim? Sorry.
I'm curious about interaction with radiation, you know, in terms of the work you're doing. It seems like that'd be an ideal environment, but I'm medical background to know, but I appreciate you.
It's an excellent question. I'm not a radiation biologist and I don't play one on TV, but clearly radiation exposure is critical to crew health on long duration missions. It's also very relevant to human health down here as well. I do know that there are some groups who are working in both the microgravity and microgravity analog environment to determine if ionizing radiation can actually, in addition to microgravity, exacerbate certain cellular responses.
Well, and some of what we've seen at NASA is that the synergy of the two,
is
radiation,
bigger than either alone. Yes.
Radiation
yes.
and microgravity are more harmful than either by itself.
So there have been, apologies, I can't cite you the specific studies. If you ask me later, I can find you and point you to those areas. But I know that there is some documented evidence, I don't know on which cell types, that do show that radiation alone, microgravity alone, certain set of cellular responses, combining the two can exacerbate those effects.
Yep. And then you have to ask the question, not that I know anything about medical science either, but you have to ask the question, what is the radiation spectrum? The electron radiation in one Van Allen belt is different from the proton radiation in another Van Allen belt, is different from the heavy ion radiation that you get in deep space. Space station astronauts do not see the radiation spectrum of deep space. And then in addition to that, each planetary surface, when heavy ion radiation impacts a planet without a significant atmosphere like Mars or the Moon, you get secondary radiation and even tertiary radiation from the Spall effects of very high energy particles impacting atoms and molecules on that planetary surface, which are of course unique to that planet. So the radiation environment in which lunar astronauts live will not be the same as the deep space environment, will not be the same as the ISS environment, will not be the same as the Mars environment. And spectrum matters.
Mm-hmm. Spectrum matters.
Spectrum matters to biological tissue.
And being able to understand and study, I mean, complexity and reductionistic, the perfect animal or human to study for biomedical problems is the in vivo, the animal or the human. But the complexity of issues you're dealing with is so overwhelming. That's why we do reductionistic things. That's why we try and break it down and look at one stress, whether it's a microgravity stress or ionizing stress at a time. But doing these kind of coupling where you're sequentially adding back in these stresses, because the cell, no cell ever has to deal with one single stress, down here, up there. And to understand which response is overriding which one when you have to incorporate multiple biological signals or environmental signals that they encounter is also going to give us different outputs.
So there are some fascinating questions associated with the strategic decision to be on the frontier and then to deal with what that frontier requires of us.
Absolutely.
I forget what time we're supposed to end. I'm starting to think that with the reception that was at 4, I'm running over.
I think we're supposed to
It's
go.
at 4:30.
Oh, okay. Oh, thank you.
4:30, yeah.
Thank you. I didn't know my own end time. So we have a little bit more time. We have a little bit more time. I want to, can I ask a question, or do we have someone from out in the audience that hasn't had a turn? Yes, sir.
Going back to the original intent of the panel, it's about society.
Societal implications of spaceflight, yes.
Right. Well,
It is. It's the only one, actually. I wrote a business case analysis and all that. It's actually the only one that does sustain itself, or in even anytime soon could. But sorry, go on.
And as someone who's spent a lot of time in the IT industry, where the IT industry is really an enabling technology that helps solve problems for many industries. In the life science community, if there are other communities, if we can convert the man, the humans in space industry from being a vertical to more of an enabling horizontal industry, enabling solutions in life sciences and energy and other sectors, wouldn't that have a greater societal impact?
Absolutely.
Well, you're posing a question which certainly with which certainly I have grappled, and quite a number of others have as well. So let me parse it slightly differently. The question you're really asking, I think, without intending to put words in your mouth, is what problems exist for society to which humans in space provide the answer, or a part of the answer. And people have grappled with that quite a lot. I confess that I haven't yet found the answer. It may be interesting to have a little bit of a discussion on that. You know, one of the answers that I offer up to that is a little bit of proof by negative. You worry about if you are the society, if your society is the one which fails to put humans in space to find out what those answers might be, then you are left at the gatepost. Others will find out what it is that is there that you don't yet know and never will. So it's a negative way to view it, and I'm tend to be more of a positive person. But I think it's an interesting question. Comment?
I have a quick comment and then a question. The comment I have is, space is the most difficult environment. I mean, you look at radiation, you look at temperature, you look at light,
Right.
everything. So when you do research in such an environment, you automatically have toughest problems to solve. To make systems work, to make humans productive, and so on and so forth.
Space is the most integrative. It requires the most integrative of engineering solutions. Is a way to put.
In addition to what I said.
Yes.
Those toughest problems. And one of the things I noticed in the last 20, 30 years is that we as a nation got led up on other nations in the technological frontier by solving these kind of problems. Now, if we
Exactly.
don't have that kind of stamina to go further, we're going to lose all this edge. Am I right or wrong? Please.
Well, I think you're right.
You are right.
You're absolutely right.
Yes.
I think you're right. But a purpose of this panel, our intent in designing this particular discussion, was to elucidate what some of those advantages and gains might be, and we've touched on a few today. If no one else has a question, I have a thought that I want to lay on the table. And this is, again, another of my aviation analogies. I'd ask us to think about the following. As I see it, okay, and I could be wrong, but as I see it, the United States became a world power by getting there first and best in a century where aviation became possible and then strategic. And we got there first and best, again, in my opinion, because of a confluence of a policy environment. Policymakers in the United States early on decided that it was the business of the government to do those things which would be aviation friendly, starting with the formation of the National Advisory Committee for Aeronautics right after World War I, whose first purpose was to answer the question of why there were no U.S. airplanes in World War I. But we created, or the policy, our great-grandparents created, with malice aforethought, a policy environment in which forward-leaning government actions to help bring about advances in aviation were regarded as a good thing. Second, we created regulations which followed that policy environment. I mean, the FAA and its predecessors have and had as their business to try to mitigate deaths from aviation, but they did not act in such a way as to restrict the freedom of citizens to attempt to figure out how to do aviation. So they struck a reasonable balance to the point where, 110 years after Wilbur and Orville, you are far more likely to die as a U.S. citizen of a lightning strike than on an air transport vehicle. You are far more likely to die of a lightning strike than on an air transport craft. That is a truly stunning result of 110 years of unmitigated effort to learn how to do aviation. Then, as a result of policy and regulation, the U.S. government took on the challenge of building a national air traffic control system. Starting, I'm a pilot, and I think most of you know that, and I love it. So the history of air traffic control goes back to people lighting bonfires across the country to provide airmail aviators with a path so that they could fly at night. And it has evolved with the times, and it always lags behind what's needed. But our air traffic control system was and remains the model for the world. That is not something that aviation could have developed without, and it is not something that any commercial entity ever could have created, sold, and made money from, because either it works nationally or it doesn't work at all. The federal government did the things necessary to promulgate the creation and utilization and protections of airports, something which is in danger of going away. A mindset was in danger of going away. And then finally provided both design requirements and designs for ever advanced generations of airplanes. There would not be jet transportation today were it not for the military requirement for jet tankers to support jet fighters. The 707 was immediately derivative of the KC-135. So I identify 5 categories of things that, starting with policy and moving down to specific tactics, that our society 100 years ago embarked upon, that produced the world of aviation that we have today. We have seen almost nothing of that in space. So I want to throw out to my panel members, what can we do, and I don't care if you're a physiologist or a tech guy, I want to know, or from the audience, what can we do if I've identified these pillars of aviation correctly, and maybe I haven't, and maybe you'll say so. What can we do to create the space analog of proactive societal behavior to generate these same pillars for space development? Policy, regulation, I'll just broadly say infrastructure, air traffic control and airports, okay, space traffic control and spaceports, and at the same time also the vehicles by which this is accomplished. Because again, I'll go back to, if the return on investment isn't there in 6 or 7 years, there's not a rational board of directors which is going to put the money forward for the creation of such things. So long speech, sorry, but now panel, over to you. Some comments on these things.
Go ahead, Tim.
I don't want to steal the floor. I'll
Floor
make
is
a
yours.
comment.
Floor is yours.
I'll make a comment in the sense that I think that in the form of regulations, the FAA has come in. It's been very good. When it comes to new areas, one of the struggles that the industry is starting to face, in a sense, is the regulatory environment that prevents it from getting a little beyond. And I think if if we kind of look at it that the government needs to protect this fledgling industry, and that's the Virgin Galactics, that's the SpaceX's, all of them, that we need to have a little bit more freedom in the regulatory environment in order to get there, and not have a resistance of the bureaucracy. And I don't mean that it can tend to be a negative effect on the business environment when the business environment, as you indicated, is a much shorter turnaround time.
So I might synopsize that by saying we need to preserve the right to kill ourselves if we do something wrong without having the government,
in a sense, it is.
destroy that goose.
When we started the space program, the astronauts knew they were on an explosive device. And if we lost one, oh, darn, let's find out what happened and let's go beyond. What may have killed the shuttle program and the cost by our time at United Space Alliance is that everyone was empowered to stop work if it wasn't safe. Now, I'm not saying that's bad. I'm not saying that. But the manpower and resources that went into maintaining that became unbearable. And if
too many people had worried about whether Chuck Yeager was going to get killed trying to break the sound barrier, and no one would have ever done it.
No one ever done it. Absolutely.
Yeah,
That's
I
my
mean,
point.
Yeah, I think that's germane. Bill or Cheryl?
I'll go after you.
Okay. It's my measure of a really good question. You sit there and you ponder the question for a long time, and the easy answer is that we have an external threat that compels us to get serious. But I have a hard time picturing that external threat emerging, other than being poked in the eye by China, maybe going to the moon or going to Mars.
But when I think back to 1920, and in the space of a decade, the creation of a mindset that allowed 80 subsequent years of aviation to develop as it did, there was no threat to the United States at that particular point.
But the threat emerged in the 30s, became kinetic in the 40s, morphed itself in the 50s, 60s, 70s, 80s, collapsed in the 90s, and that collapse occurred roughly about the time that our space program became, I don't want to say inert, but became much less focused, much less creative, much less strategic. So the easy answer is that we can formulate an approach to space that emphasizes the strategic nature in response to a challenge or a threat. But we dominate in political terms, largely in economic terms, clearly in technological terms, though we can debate that a little bit, and we dominate in the cultural sense of we establish the norms by which people engage in discourse, minus the authoritarian regimes like Russia, China, and others that are a contending set of forces. So I guess on the question for us is, how do we compel, in a democratic, free market-oriented society, a strategic conception of space, where I'm sort of gravitating toward, no pun intended, sorry, is, I'm reminded in comments like that, don't give up your day job, is the classic expression. I'm keep thinking of what Cheryl's been saying, and I'm wondering if there's this potentially great breakthrough that could occur in the medical sciences, the life sciences, as a function of space, and I don't know the answer to that, and I know Cheryl's been thinking about it a lot, and then I'm wondering if it is a potential, why don't we know this? If this is a big message that's coming out of the scientific community, that this could really change the nature of health, it might move us in very interesting directions and rebuild the societal consensus.
Well, when you
Over to
have the National Institutes of Health in this country,
Yeah.
whose sole job is to conduct fundamental, basic research with the goal of providing new insight to advance human health and all the major human causes of morbidity and mortality, when the National Institutes of Health signs a memorandum of understanding with NASA to fund spaceflight research, and they do. They fund it for 3 years. They're not funding it right now. It's a
I think
problem.
they signed it under me. I think I was the
I think you're right. Yeah,
co-signatory.
yeah. So, my God, thank you, Michael. I mean, amazing. This speaks volumes. Nobody is guaranteed. I want to make one thing clear, because sometimes, over-the-top claims can get made, right? I don't allow my team to ever use the word cure. It's not allowed. If anybody remembers what happens back in the Nixon days when they said, we're going to cure cancer in the next 3 years, it diminishes the value of support you get from the general public when that magical cure isn't there. It diminishes the value of that platform in the eyes of scientists and in groups funding it when you don't deliver. So no responsible scientist will guarantee you that you're going to have the next generation breakthrough discovery using any platform, whether it's in your lab or whether it's up there, because you don't use the word guarantee. But one thing I will lay my life on is that there is enormous, tremendous potential that this extreme environment, like other, it's not like other extreme environments, but by analogy, that other extreme environments have provided to translational breakthroughs in a wide variety of human health and biomedical areas that we use on a daily basis. The potential is there. We cannot afford not to do this. Now, by follow-up, NASA, I think, made a prescient move in selecting a nonprofit group to actually start to do that, to manage the portion of the ISS National Laboratory, to return the investment on the 75 billion, is that what you said? 75 billion?
75 billion was the best number I could come up with.
Okay, good, because I see those numbers fluctuate too.
Yeah.
We promised the American public, we promised you, me, all of us here, all the taxpayers, a portion of why we're doing this is to return investment on your monies that you put into this, to give you new strategies, to give you new therapeutics, to give you in the life sciences that are going to translationally advance your life and make it better. We promised you. So NASA, not being in the business of being in that business, said, we're going to pick this group, this nonprofit organization, and we are going, their job is to pair commercial investors who have the deeper pockets, okay, with the scientists who have these really great ideas about how to use this novel platform to discover all these innovative biomedical advances that we can bring back down to here at Earth and translate it. The problem is, and we need that group to succeed, the problem is there's been a very slow curve and a slow startup, and maybe if we could come up with innovative ways to help them succeed, because we need them to succeed now. I think that is because NASA already understood we need this. We need this, and we make this happen. But it seems to be happening very slowly.
It's, of course, contingent upon transportation.
Transportation is essential.
I hate to make it
But
so
you do
pedestrian,
have,
but
you're
it
right.
is-
We need to, in a perfect world, what will we do? In our laboratory, you're doing experiments 24/7. My lab is
Right.
open for business 24/7. You continually advance on that
If
work.
I can't
and
get
that's
to my business location, there are things for which telecommuting just doesn't work.
Yes, that's right. But even now, in the absence of being able to get there on a very frequent basis, I mean, many of us are some of us are flying on, going to SpaceX, some going to ESA, some working with other, you can get good research up there, okay? But where is that magical funding that's supposed to be pairing that research with commercial groups for the scientists? And I think if we can make that happen better, I don't run that group. I mean, that's one heck of a job, okay? But I think we need to help them succeed better, because nothing succeeds like success. Science drives exploration, exploration drives science. You can't have one without the other.
Yep. Okay, the last remark is going to be Bill Martell's.
I don't have the last one, but.
Well, you have it, because we're about running out of time, so the last remark is yours.
A really quick comment. For the first 50, 60 years plus the space program, it was a government-dominated model.
Right.
And now the thought experiment's being conducted whether we can actually see that drive coming out of the private sector. My own view is I'm very much a private sector kind of person. And I'd like to think it's going to work. What's unknown to me is, can the private sector harmonize on something really big, strategic, and critical that can help capture the public's imagination and attention and keep the policy community in
Well, see, I think...
I think we can.
Well, maybe we can, but I think there is some... I too am a private sector guy and a fiscal and political conservative, but I struggle to imagine how a private sector initiative could have given us an air traffic control system. I struggle to see how a private sector initiative could ever have given us the interstate highway system.
I confess to the same.
Yes. And so,
This gentleman was dying to say something.
So, yes. No, go ahead, Jim.
Go.
You know, because I'm in the industry too, in the last 4 years.
Yeah, and you and I have spent most of our life in government service, and now you're in industry.
But, you know, and I can't argue with you about closing the business case. That's true. Let me give you you know, we're starting a new business in satellite servicing.
Right.
With ATK. And we got to a point where the business case absolutely closed, and we showed it time after time after time, but we didn't really get past that threshold until we stopped and said, look, this is a simple life extension vehicle. There's no excitement here. There's no new technology, and it's really boring when you get right down to just simple docking and life extension.
Well, that's not a problem for a business case.
But the way we finally got the customers and the investors was when we laid out a global vision. Said, yeah, and this is the first step before we become an intergalactic space logistics company that's going to help carry stuff to and from the L points and the moon. We're going to do on-orbit repair, and we laid out a larger vision. And it's like, oh, there is a lot of place to grow here. It's not just that one little closed business case.
Well, that was my point earlier about if people think there's a time horizon like 2020, or you pick a date, if people think there's a time horizon, all of a sudden they start to want to pull back. You see, the thing you're offering is an example of exactly that thinking. You close one business case, but people want to see what the global future looks like.
And then wonder what happens if our competitors in space are essentially command economies approach, and maybe we're starting to be this hybrid between, you know, mostly government now to government and private sector, maybe more private sector.
Well, and my question was, how do we do it? Jim, I'm going to give this gentleman in the sweater the last comment, and then we really are done. So, sir?
Yes, sir.
Kind of a comment about where does commercial communications, space communications, kind of fit in this whole framework? Because if you wanted to kind of be the red team here, and probably driven by the time horizon, but you could say, well, what's the problem? You know, here's this huge multi-billion-dollar industry that developed fairly quickly, maybe 5 or 10 years. Admittedly, it had government involvement and regulatory and all that sort of thing. So.
Well, here are some interesting statistics on commercial communications satellite as a business. Okay, leaving it out as a technology. Let's just look at it from a business perspective. From a business perspective, and this is the only thing so far that we've found in space, not that we couldn't, I mean, other things could do it, but we haven't got there yet, that has this characteristic. An investor who can obtain from his or her government a license to put up a communications satellite will find that the investment required is about $500 million, round numbers, very close round numbers, which is large but not impossible. That investment does not have to be done all at once, but pretty close. It has to be done over about a 3-year period. Mm-hmm. And at the end of that 3 to 4 year period, the object will be in place, generating revenues. It is possible to buy insurance for a failure of the object to materialize, in which case the investor gets his money back, but he doesn't make a profit, but they don't lose all their investment. After, and if we define time 0 as the point where you decide to make the investment, then 3 to 4 years after time 0, you're in place generating revenues, and by the 8th or 9th year, you break even. Right around 8 to 9 years, depending, you break even. The object will have a useful lifetime of about 15 years, which starts on year 3, so 18 years after the initial investment. So the object will have a useful lifetime of about 15 years. So from year 8 or 9 through year 18, you're printing money. When you turn I mean, I have an MBA and occasionally it shows. When you turn the time value of money crank back to time zero, the net present value of that investment is it will give you about a 13% IRR on your money. That contrasts with alternative and it's almost perfectly safe. Okay, once you get them on orbit, you can't kill these things.
Yep.
They run out of propellant after about 15 years. That contrasts with putting your money in the stock market, say an index fund, Dow Jones or S&P 500, or you pick it. That contrasts with a return on investment, an IRR of about 10%, just under 10. So as an investor, if you don't give a rat's ass about where you put your money, pardon me, but are just looking to generate a return, you get a 33% premium on your money by buying a ComSat and putting it in place. And it's almost perfectly safe. So it's not any wonder that business makes money.
Yeah.
Okay? It's a license from your government, whoever you are, whether you're from here or Saudi Arabia. To get a license to put a ComSat in place is a license to get a 33% return over an index fund. And that's real attractive. The problem for us space geeks is we haven't found, maybe medical will give it to us, maybe there's something else that I haven't thought of. We haven't found the thing in spaceflight to be the number 2 business case. There's not. We just haven't found it yet. And so we're over time. That's truly the last word. Thank all of you for attending. This is the kind of thing I think AIAA should be doing, and I hope you'll see more of it. Thank you.
Mike, thank you.
Thank you.
Thank you.
Yeah.